In 12.3, we are going to talk about different types of light bulbs, different types of ways that, or gases that light bulbs have that cause different emission of light. So the first light bulb you probably heard of is called an incandescent light. This is pretty common. You probably have a bunch of these light bulbs in your house. But the definition for incandescent light is basically light that is generated by heating a piece of metal that is inside of the light bulb until it glows. So what is this piece of metal that is inside the light bulb? It's called tungsten. It's called, the actual piece of metal is called a filament, and the filament is made up of this wired, it's a wire that is coiled, and it's made up of tungsten. And tungsten is a pretty hard metal, meaning that it is pretty dense. So in an incandescent light, we have this tungsten, like I said, is a filament inside of the light bulb, and it causes a level of resistance. So you don't have a full flow of current. So when current is actually flowing through it, it's going to build up heat because of this resistance, and light is going to be emitted off as this buildup occurs. 90% of the energy that is given off by these incandescent bulbs is actually heat, and or aka a form of thermal energy. Remember, thermal energy always has to do with heat. So now that we talked about incandescent light, there's also another type of light called fluorescent. Now, fluorescent is when you have light that is being generated because of something called phosphorus. And you need this substance in order to convert UV light into visible light. So phosphorus converts, like I said, UV light into visible light. And that is how light is going to be emitted from this type of light bulb. Phosphor itself is actually a substance that absorbs the UV light, and that is what is going to cause the emission of visible light. So in this diagram, you can see an example of a fluorescent light. You might have these at your house as well. They can look like the image on the left, or they can look like the image on the right. So let's talk about fluorescent light. First thing is, a fluorescent light bulb is actually going to be filled with a gas. And it's going to be filled with a gas at super low pressure. The inside of the light bulb is going to be coated with phosphorus, and they're going to have electrodes at each end of the light bulb. So you can see that in the image. You can see the electrode on the inside and the outside. You can see the gas that's going to fill in the space, and then the coating that is going to be coating on the inside of the light bulb. So what happens? When these electrodes are connected to a circuit, you're going to have electrons that are going to be emitted. These electrons, once they're emitted, are going to collide with the gas molecules that are inside of the bulb, and this is going to emit a UV radiation, or ultraviolet radiation. Now, depending on the type of gas you have, different wavelengths of light can be emitted, but we'll talk about that later. Once you have UV radiation being emitted from these gas molecules colliding with electrons, the phosphor inside of the light bulb that you use to coat the bulb is going to absorb this UV radiation, and it's going to convert it to visible light, which is what we see. Fluorescent lighting is actually really efficient. Fluorescent lighting uses about 1/5 of the energy of an incandescent light bulb. It lasts longer, it's lower cost, so it's more efficient. And that's why a lot of people prefer incandescent lights over, prefer fluorescent lights over incandescent lights, especially in buildings that have to stay for a long period of time. So hospitals that never shut down, they use fluorescent lighting. Schools use fluorescent lighting. They're just very beneficial and cost efficient in those types of environments. Now let's talk about neon lights. So you probably seen neon lights. These are like bright glowing lights like you can see in this image. And they're super, eye-catching at concerts or on this, road signs. They can be used for just getting your attention, whether it's for something in like parties, celebrations, or like I said, something crucial like road signs that you need to have people look at to get their attention. So neon lights are pretty much glass tubes that are filled with a gas. And can you guess what gas it is? If you guess neon, you're absolutely right. And they're similar to fluorescent lights. So what happens is you have an electric current that is going to flow through the tube that is filled with this neon gas. The electrons that are produced from the electron current is going to collide with the neon gas molecules. When gas and electrons collide, you get visible light. So you can kind of see that in the image. You can see that the light, which are those red arrows, are colliding with the neon gas molecules, and they are producing, you see the electrons which are the little red balls in the image, are colliding with the neon gas molecules, and they're producing the red arrows, which are the light that we actually can see. When you have neon gas, they can usually expel a bright red or orange color. There are different types of gases that can cause different types of colors, such as argon gas produces green, phosphor can produce other colors of gases as well. There's another type of light called sodium vapor light. This is mainly used for street lights and outdoor lighting. Inside sodium vapor light, you usually have a tube that has a mixture of two types of gases. It's usually neon and argon gas, and then they also have some sodium metal inside of there. This combination allows for you to see the visible light that you can actually that we can see on the side of roads. So how does this work? When you have a lamp on, the gas mixture inside of the lamp becomes super hot. This hot gas mixture causes the sodium metal to become vaporized. When this hot sodium vapor is, when the sodium metal becomes vaporized, because it's being heated up, it's going to emit a yellow-orange glow, and therefore that is what you see on street lights or outdoor lighting. There is another type of light called tungsten halogen light. This can be super bright, and remember, tungsten is the filament that they use inside of incandescent light, but in this case, they also use tungsten as a filament inside of a quartz bulb or tube. Quartz bulb is a type of incandescent bulb. These types of light, the tungsten halogen lights, last longer than incandescent light. And so the tube or the bulb that contains the gas is usually going to be filled with one type of halogen element, so it can be fluorine or chlorine. And the presence of these gas molecules makes the tungsten hot, more hot than an ordinary incandescent bulb, and therefore the light is going to be a lot more brighter. And that's what it says here. So like I said, these hot gas inside of the bulb makes the tungsten, which is a filament, really, really hot. And it causes a brighter light than a normal incandescent bulb, which doesn't get as hot. Talking about lasers, you can have laser from, whether it's at a show or even in surgery. You can actually have a lot of laser surgeries, whether it's breaking up kidney stones, or some people use it for incisions and things like that. But lasers are made up of gases, liquids, or solids. And the wavelength of the laser depends on what material is being used. So one of the most common lasers that we use today is called a helium neon laser, which makes a red light beam. The wavelength of it is about 632 billionths of a meter. So this is usually what you can see in everyday use and everyday functioning, whether it's in classrooms. You can see this. I have one of these in my classroom at the end of my clicker. And a lot of people will use this in teaching. Okay, so when we talk about amplifying light, we are going to be talking about helium neon laser. So helium and neon gas are going to be absorbed, are going to absorb radiant energy from a flash tube, which is a type of lamp that makes intense light. So as the gas, helium and neon gas, as they take in energy, it's going to cause short and bright flashes of light. So what happens is the atoms are going to then release extra energy by emitting the light waves at a certain wavelength in all directions. And this is going to cause a chain reaction to move through the tube. Now we're going to talk about coherent light and incoherent light. So when you have a coherent light, the wavelengths of a coherent light, as you can see in the diagram, at the bottom diagram, they're going to be the same wavelength, they're going to be identical, and they're going to be in the same phase. So they're only going to have one specific wavelength, they're all going to travel in one direction, they're going to have the same distance between the crest, which is the top of the wave, they're going to have a constant wavelength and frequency, and they're going to have the same phase of photons, which is light. So this is an example, would be a laser light. Incoherent light, though, is going to be, as you can tell in the top image, light with more than one wavelength. So it's going to travel in multiple directions. It's not going to be constant. The distances are going to vary between the crests of the waves. And there are going to be random changes in the phases of photons or phases of light. And this is a light bulb. This would be an example of a light bulb. In the previous image, I'm going to go back for just a second. We also see in the middle monochromatic incoherent light. This is basically, they're all going to be the same color. They're going to also have different, more than one wavelength, like the incoherent light. And they're going to have random changes in the phases between the photons. So you can see that happening, that it's more like incoherent light than coherent. They're not very cohesive. So lasers have different uses. You can use them in CD players. You can use them as surgical instruments like cataract surgery, which is basically surgery for cleaning out cloudy lenses of your eye. Which can cause people to have less visibility. LASIK eye surgery, which is lasers that shape the inner cornea of your eye, which can also cause people to have a lot of discomfort in their eye with vision. You can use lasers for cutting, for welding, and construction, and even your DVD player when you watch movies. These are all uses for lasers.